Namaste, welcome back to Sthita Pragna channel, and you are watching Cloud Quest series, and I will consider this as series 3 because in series 1 and 2 we have covered cloud practitioner projects and then solutions architect projects, and in this series we are going to cover data analytics projects. These are real-time projects that are actually being implemented in different companies. So if you are looking for some real-time AWS projects, you are in the right place. And these projects are, we will be doing these projects as a data analytics in the data analytics role, right? In the first series, we performed those projects as cloud practitioner role. Second one, we did it as solutions architect role. And this series will consider me as a data analytics engineer working in a company, and will be implementing these different projects, not in a company, maybe in the AWS, and will be implementing these different projects. And as you know, we have 3-4 more series that will come. One as a machine learning, another one as security and DevOps, etc. So we can get to them later, but let's start this particular project. And if you are new to this series, you know, this is a role-playing video game where in role playing there are different roles, and each role has different quests. We already finished playing as 2 different roles, cloud practitioner, solution architect. If you haven't watched and if you're new to AWS, I would recommend you to start with cloud practitioner and then get to solutions architect and then come here, because the concepts here will be advanced compared with the other 2 roles. So watch them in order and come here and then watch this. So how this works is, initially, you know, we will have this world. In each world there will be different islands. Each island will belong to a particular role where there will be different projects. Projects will be given by the NPCs or citizens in this island or on this island. We will go to each one of them and they will assign us, not assign us, but they will tell their problem, and as data analytics we will give them solution and then we will implement it for them. That's how it works. And along with that, we can zap drones. As you can see, drones flying around. So there will be blue drones and then there will be orange drones. So blue drones, when you zap them, like shoot them, what happens is you capture them by answering a question related to whichever topic you finished. And orange drones are something like wherein they will ask us an architecture question and then we have to place in some blocks. You know, if you played jigsaw puzzle, right, it will be similar to that. And those cards we will earn by zapping the blue drones. So you zap blue drones, you earn cards, then you will use those cards to play those architecture related games when you zap orange ones. So usually how I do is, initially I will go and pick the project and then I will implement it. Implementing it means this Cloud Quest actually gives us access to their labs, real-time AWS labs. Then we will implement it, which means I will show you how we handle that particular scenario or the project. And once it is done, I will start zapping those blue drones. So you might be asking, how many drones will you? Well, there will be a limited number of questions each time you finish a project. So once they are out of those questions, they will be repeating. As soon as we figure out, okay, they are repeating the questions, we can stop it there, stop zapping the blue drones. After we have enough cards, then we can zap the orange ones, but I don't think we will be zapping orange ones in the first video because we would need plenty of cards to do that. Okay, that being said, we can go and look around for people or these islands and then get to the people who have an exclamation mark on top of them, which means they have an active project. But we have a shortcut. We can click on our mobile phone and there it will show what are the different projects that are available to me. And along with that, I forgot to mention, there are pets as well throughout the world. We can go and capture the pets or make them our pets. But how it works is, depending on the pet, you have to go and talk to them multiple times. Each time you talk to them, they will ask you a question. Obviously these questions are again related to whatever concepts you are learning. And if you answer successfully, then that pet will become that much closer to you. So a particular horse, let's take, maybe it needs 6 times you need to go and talk to it, and then it will give you a question. So once you do it, it will disappear from there, and next time it will appear. So as you can see, we see this one, right? This is telling you how to go to our, there is a nearest pet. It is telling us, you can follow that direction and get to that pet, which we will do once in a while, not now. That being said, I would really appreciate if you subscribe to this channel so that you don't miss all this amazing content. And you already know we have a certification question series as well, playlists as well. Go ahead, watch them, and you can look at the comments. All the questions that we put, mainly people like the keywords that I give, the tips and tricks that I give instead of the question and answer. They like that part because it will make you to remember them, learn concepts very easily. So if you are planning to do that, go ahead, you can watch them and appear for your exams. And I never at least got any comment in any of these videos saying that they followed my instructions and failed the exam. Actually, we have a competition going on in the Cloud Practitioner wherein who will finish the exam faster. Right now the record is 23 minutes, which is awesome. I don't think anybody will beat, but I thought the same. When somebody finished in 25 minutes, I thought nobody will break it, but there is another person who broke it by finishing in 23 minutes. Yes, I'm talking about a Cloud Practitioner exam where it has 65 questions and they finished the exam in 23 minutes, which means in a minute they answered 3 questions that fast, and they passed with amazing score. It's not like they barely passed. Okay, so that's how we have these videos and playlists that will prepare you to not just answer the questions, but also at a faster pace. That being said, let me click on my mobile phone, and currently we have 2 projects. We are going to do this one. We can go to that person, but by clicking this, it will automatically take us to them, so we don't have to roam around. Okay, we are on serverless island. Here, as you can see, there will be an exclamation mark. Let's click on them. Hello, I am the CTO of Island Gamers, and I also own most of the arcade games in the city. Thanks for coming. I love games. How can I help you? We have a central dashboard in our cafeteria that is supposed to provide real-time updates of the top 5 players per game along with their corresponding additional information. We are currently experiencing long load times for initial player data on the dashboard. The new updates that track the top 5 players are also extremely slow. So as you can see, the customer, this is like real time. Okay. For example, let's say you are working for AWS as data analytics engineer. Okay. So this is how you go to customers. They will tell you what their problem is. Then as a data analytics engineer, we provide the solution and we implement it. So right now, this is our customer, our client, and they are explaining their problem. Then we will analyze what they want. Based on that, we'll provide a solution. I have no idea what is causing this. Can you help? Sure. What type of database are you using? We are using Amazon DynamoDB. I need to examine your table. We might want to create a secondary index to speed up searches. How will that help us? Well, creating a global secondary index is like creating an additional DynamoDB table that contains a subset of attributes from the source table with an alternate primary key. A secondary index speeds up queries on non-key attributes. You can provision the index with lower write throughput than the base table, while still achieving excellent performance. I think I see the issue. Our table has numerous attributes coupled with a large amount of player data. Our custom query has to perform a scan operation, which makes retrieving the top 5 players per game very slow. Did you create an index that uses each player score as a sort key? No, we did not create a secondary index after creating the table. I think we have a solution. Let's create a secondary index on your table that you can use to quickly query player scores for each game. Can you help me create a new index for my table? I have never done this before. So you can see it, right? As soon as they explain, we give solutions, then these will be populated, which are the learning objectives. So after doing this project or watching this project, what will you be learning? You will learn how to create a global secondary index, and use player score as a sort key in the new index. That's all. That's what you will learn. And since you finish the assignment or project, you will get these rewards. Gems, you can use gems to buy different buildings on the island. Then you have customization options for your character. Then you will get plus 10 AWS Cloud9 and AWS DynamoDB knowledge. So as you can see, we are going to use Cloud9 and DynamoDB as part of this particular project. That's why we will get that experience. Let's click accept. Great. After you deliver the solution, I will let you redesign our building. Yeah, that they will give us a reward at the end. But as you can see, now once I click start, it will take me to the lab. Okay, by the way, if you are wondering how you can do this, well, the first Cloud Practitioner Cloud Quest access is actually free. You can go ahead, register, and you can do, I think there are about 12 projects that you can do as part of Cloud Practitioner role, which are completely free. They will give you labs as well, which are free. But if you want to do anything other than that role, then you have to pay. I think you can have an yearly subscription for I think $200 or plus or monthly subscription of I think $30. I am paying because I want to show you guys, how real projects look and how you can do it if you want to learn about more hands-on. So I am paying it. So I expect you to watch this very carefully and learn from it, because if you guys don't, then I'm paying money for nothing. Okay. That being said, once we accept the project, we will have the architecture diagram shown, the current architecture, and how we are going to change things so that we can successfully deliver the project. And on the left side, you will see video concepts, each video concept regarding whatever we are going to do as part of the project. As usual, there will be videos. If I click on video concepts, videos related to the topics that we are going to do or use, services that we are going to use in this particular project. I'm not going to play them here, but you might be like, oh, I want to watch these videos. Yes, I got you covered already. So these videos are already placed on our YouTube channel. The playlist name will be AWS Tutorials for Beginners. So go to our channel Sthita Pragna and go to playlists, and on the playlist you will see one playlist called AWS Tutorials for Beginners, and in it these all will be already placed. So just take a look at them and then go and watch those videos before continuing to any of these if you already don't know those concepts, because you won't understand the project if you don't know these already. So I recommend you to go watch these videos. You can pause this video, go there to that other channel, not another channel, other playlist, watch those videos, come back and continue watching this. Okay, what do we have here? Okay, diagram, as you can see, diagram steps 1 out of 7. Okay, step 1, Amazon DynamoDB table design should be governed by the data access pattern. Every read and write that is made to a DynamoDB table has its read usage or write usage computed, which you can see from the DynamoDB table here. You have the API gateway where the users will be hitting, then a Lambda function will trigger, which will get scan or query from the DynamoDB table. In this solution, indexes provide access to alternate query patterns, which you can use to speed up queries. After you create an index, the database maintains it for you. Okay, so you can see there are global secondary index, batch game index, and then there is another global secondary index which is game top scores. Okay, so this index has partition key as batch, sort key as game, and here partition key as game, sort key as score. If you don't know what global secondary index is, go watch them. But global secondary index is another type of index, secondary index, where you can create where you can have a separate partition key. It doesn't have to be same as the base table. A global, they are explaining us. It contains a selection of attributes from the base table, but they are organized by a primary key that is different from that of the table. Okay, so that is the difference between the local secondary index and global secondary index. Local secondary index will share the same partition key as the base table, whereas global secondary index doesn't have to. Using the badge game index GSI, you can quickly access the data of all players with specific badges sorted by game. Makes sense because your partition key is a badge. So you will have all players with specific badges sorted by their game. And using the game top scores GSI, you can quickly access the data of all top scores per game sorted by score. Makes sense. Whether you are using a relational database or the DynamoDB NoSQL Database service, you should be judicious with index creation, which means like careful. Whenever a table write occurs, all of the table's indexes must be updated. In a write-heavy environment with large tables, this can consume large amounts of system resources. So that's what you should be aware of regarding indexes, right? Every time you write, indexes has to be updated, whether it is manually or automatically, they have to be updated. Okay, now we are equipped with the knowledge in order to implement this project. Now, as usual, we will have practice lab goals wherein the Cloud Quest is going to show handheld. They are going to show us step by step procedure, what to do, etc. So they are going to spoon feed us. Once you do that, then you will have DIY section wherein they just tell us what to do and we have to do them on our own. They won't tell us how to do, etc. But there will be, after the end of DIY, there will be a section where you will put something in to check whatever we did is actually right or wrong. So let's enable this, and this is what we are going to do. We are going to review the DynamoDB table structure, how the structure is. Then we'll compare the scan and query operations. Then we'll explore the filter expression and limit parameters. Then we'll create a global secondary index to optimize the search, and then compare query performance by using the created global secondary index. We'll do all those things. And as part of DIY, so we are going to do this, and DIY we are going to do the game top scores. We'll create additional global secondary index. Then we will use the correct partition key, which is game, and the sort key score. Got it? So let's click practice now. So here we can start the lab. Let me start the lab. Oh, it is super fast. It's already available for us. So we can go into the lab, and these are the steps that it is just going to tell us. Review the goals, then start the lab, then etc. It is talking about labs. If there are any files we have to use related to this, it will be under this. For this project there are no files, so we are good. Let's click open AWS console. Alright, here we are. But before going into it, okay, here we are. Let's click on step. There are 36 steps, which means it's a medium length project. So they are asking us to go to DynamoDB, and on the left side they will explain us each about some concepts like what that tool is, etc. So just make sure that you read this as well, don't skip it. Amazon DynamoDB is a key value and document database that delivers single-digit millisecond performance at any scale. It's a fully managed, multi-region, durable database with built-in security, backup and restore, and in-memory caching for internet scale applications. And once you go there, they already created a table for us, which is player score. Remember, we are going to just review the already existing table structure. Then let's click on it. Once you go inside, you will see tables, items, attributes are the core components that you work with within DynamoDB. If you are new to DynamoDB, think of this is kind of similar to our relational database tables, which are tables, but in relational we call rows, here we will call items, and in relational we call columns, here we call them attributes. So don't get confused like, oh my god, what is items, attributes? It's the same, it's just naming convention is different, and they are explaining it here as well. A table is a collection of items, and each item is a collection of attributes. DynamoDB uses primary keys to uniquely identify each item in a table. DynamoDB supports two types of primary keys, which is partition key and sort key, referred to as a composite primary key. And once you go there, you will see different items, which are different records, again different rows. in the player score table, the combination of player name and game timestamp forms the composite primary key. As you can see, player name and the game timestamp. Review the attributes, etc. Partition key. DynamoDB uses the partition keys value as input to an internal hash function. The output from the hash function determines the partition in which the item will be stored. Sort key. All items with the same partition key value are stored together in sorted order by sort key value, which is I think, what is the sort key here? I think the game, maybe the global index, we don't know. We'll see. I don't know. I think they will explain us. Let's go back. The query operation in DynamoDB finds items based on primary key values. You must provide the name of the partition key and a single partition key value. The query returns all items with that partition key value. So this is kind of like doing a select. Okay, so we went to there, we'll click on that, then we'll choose the query, then player name, which is a partition key, you have to give it, and we are selecting for the James Smith, and when you run it, it will return all the items or records or rows that have the James Smith as the partition, which we will do in a minute. As you can see, which is what you will see. Query operations in DynamoDB typically consume a lower number of read capacity units, which they call it RCUs, than scan operations, which need to read through all items in a table. Remember that scan means it is reading the entire table. Query operation means it is not scanning everything, but whatever partition you are going to mention as part of the query. So that's what they are telling you here. Okay, then they are telling us to do something else. So before we forget that, let's go and pick DynamoDB and let's finish that first thing that they are telling us to do it. So here they don't have it. DynamoDB. Tables. Okay, we have the player score table. Okay, actually they already created it here. Partition is player name, sort key is the game timestamp. So that's why it's already ordered in that. Okay, so we are here. You can see tables. The only table we have is player score. And if you come here, you can see the partition key and then the sort key and the capacity mode, whether the table is active, alarms, and there are other which we don't want to go right now. Okay, what do we want to do here? We want to explore table items. So let's click that, explore table items, which is where we are here. And they've asked us to go into the scan or query. Scan is full table scan, it will return everything, but we want to do query. And as soon as you select query, you have to select a index. Select a table or index. We don't have any indexes yet. It looks like we have the table, which is player score. Do you want to select all attributes? I am fine, but you have to give the partition key. What was the partition key they used? I think some James, what? Did they use Jennifer Davis? I thought it is James. James Smith, yeah, they used James Smith, never mind. I was confused. And if you want to give the sort key, you can, equal to, etc., but it is optional. That's fine. Even if you don't give it, that's okay. But as you can see, we have got 50 records for the partition of James Smith, nothing else. You won't see anything else other than James Smith. And our game timestamp is the sort key. So you can see that sorted already and giving us the result. That's it. It's as simple as that. So when we did that, it didn't do the table scan. Complete full scan, it didn't do that. Whenever you run any query operations, it won't. It will only read whatever partition you give, not the full table. You need to remember that. Okay, now they are asking us to go to scan. This time we are going to do scan. And then filters, they want us to put attribute name, which is column name batch, and the values champs. So wherever column values champs, that we are going to print. Okay, so you can see there are going to be RCUs consumed 266. I think whatever we did previously, the scan, I don't think we consumed that many. I don't know if it showed here. Okay, it didn't show us here, that's fine. A scan operation in DynamoDB reads every item in a table. By default, a scan operation returns all the data attributes for every item in the table. If you want to further refine the scan results, you can optionally provide a filter expression. Let me see, what is it? Champs. Okay, we'll do that in a minute. Okay, now they are adding another filter, which is game, and they are saying equal to Card Brothers. So they want badge champs and the game Card Brothers. And again, RCUs looks like it's the same. A filter expression determines which items within the scan operation results should be returned to you. All other results are discarded. A filter expression is applied after a scan finishes, but before the results are returned. This is important because this is a certification question they will ask you. But what they are trying to say is, whether you apply filters or not, it is going to do the scan first. It will go through each record first. It will return the, but when you apply filter, it is going to give you according to the filter and discard the remaining. So don't assume when you put a filter, it is going to not scan the database or table. It is going to. So scan happens first, then the filter is applied on top of scan. Remember that. So let's go ahead and do that as well. So let's click on scan. Same thing, filter first, they picked an attribute. Okay, why is it a different table? No, it is the same table, right? Player score attribute, why do I see what is different here? Okay, maybe reset. Okay, that's fine. Okay, that's not it. Something is not right. So let's click explore items. Click on the table. Explore items. Scan. Still the same. Is it the same table? Let me go here. Scan query. Okay. I don't see badge. Do you see a badge column in there? I don't see a badge. That is weird. Huh. Okay, that's fine. This they put it as Card Brothers. Okay. Oh, now we got the badge. That is weird. Okay, as you can see, even though it didn't give us that option here when we are trying to type it, it is only giving the sort key and the partition key. So maybe we may have to. So let's put that name as badge, and they want it as almost forgot about champs. Let's run it. Wow, we only got one record, but I don't know, for some reason, oh, it's still giving, it's still querying. Okay, query it out. Okay, this is slow, that's fine. But you get it, right? So we can give filters as many as you want, but whenever you are doing this, remember it is will scan first, then on the scan it will apply filter. So okay, 266. Oh, it's going to be the same, huh? RCS, you can see that. Okay, we got 4 records that satisfies this these filters. So let's go back. Okay, now that being done, they want us to open Cloud9. If you don't already know Cloud9, then I would recommend you to go watch from the beginning. I want you to do the Cloud Practitioner first. So Cloud Practitioner establishes your knowledge on most of the tools that are on AWS. And then Solution Architect takes it a step further, where it will tell you where each tool fits in what scenario, and then come back to here, because this is kind of an advanced. So if you don't know what Cloud9 is, you need to go watch them. AWS Cloud9 is a cloud-based integration development environment, which is an IDE that helps you write, run, and debug your code with just a browser. It includes a code editor, debugger, and terminal. AWS Cloud9 comes pre-packaged with essential tools for popular programming languages, including JavaScript, Python, PHP, and more. So you don't need to install files or configure your development machine to start new projects. But again, it is going to cost. It's not free. So once you go there, I think there's already one they created for us. So all we need to do is click open. In the behind the scenes, it is going to use obviously EC2. And once we do that, they want us to view themes Xcode. Are we going to do some iOS development or what? I don't know. Let's see. Maybe that is not what they want to show us. Choose themes. I think all they are saying is themes. Then Xcode theme. Okay, we'll select that. And then change the main theme. Yeah, sure. Why not? And then once we are there, new terminal. Okay. I think I will remember that. In the new terminal window at the command prompt, run this one. So I think I will definitely forget about this. So what literally we are trying to do is we are trying to, I think, clone a Git repository that they already have on code commit. Code commit is Git on AWS, if you already don't know. So let's go here. So let's open Cloud9. And they already created one for us. Click open. Okay, that's good. Then they wanted us to go into view, themes, Xcode. Yes, I want to. Now let's go pick a new terminal. Then we have to copy paste whatever we copied. Yes, allow it. So we are just cloning whatever is in there, which is DynamoDB tests. So it is going to bring that Git here. You can see that it is still doing it. Okay, it brought in everything that is there. So now let's go back and see what they are going to tell us. Oops, this is the problem with it. I cannot go to and fro between my tabs. Oh no, it is still taking me here. So how do I do it? Still nope. Okay, that's fine. I'll just have to come out of the full screen. Okay, so here we are. Let's click next, and they want us to cd into that Git folder. Then they want us to sudo pip3 install requirement. So looks like there is a requirement document in this one, wherein they might have certain requirements that they need. So let's copy this, and that is going to install it. And in the left environment window, click to expand that. Okay, so they want us to open this particular file, get item. Get item means we are going to read the record. Okay, so open that, then we'll review it, and then I think all we have to do is run it. Then DynamoDB provides the get item action for retrieving a single item by its primary key. Get item is highly efficient because it provides direct access to the physical location of the item, which is good, right? So we are going to use get item to do what? To read a particular record by its primary key. And it says single item, which means single row. Remember that. Get item, single row. If you want to get multiple records or multiple items, then there will be some other action. Okay, that being said, let's go here, and they want us to cd into the DynamoDB. So right now we are here. They want us to go here. So let's click Dynamo, tab it. So I think if I list, I think we can see all the files here. What did we want to do it? We want us to run this pip command requirements, because there is a requirement document here. If you open that, all it has is tabulate boto3, so it is going to install those two. Tabulate. I think tabulate shows you in a tabular format. It shows data in tab. So Control L, I don't know if it works. Well, it worked. Now they want us to open this file and see its content, which we can see. So it has multiple functions. If you are not familiar with Python, that's okay. This will be I will just give you an overview. So what this function does, it prints player data, and it is going to get a, I think, list, right? It is going to get list, get result item, and from it they are going to select item, and then they're going to print it using the tablet, which means it is just going to make the records look pretty like a table with columns, which is header. And then they have other function, convert player data to array. So they are going to get the player data, they are converting it in an array or list, whatever you want to call it. And print capacity, then print data. These are all print, but technically what I want you to concentrate is this one. So they are going to create DynamoDB connections using boto3 resource, and then DynamoDB they are creating the instance for the score table, like table name. These are the commands that you need to remember. And then they are just creating a variable that will store the current timestamp. Then how are you getting the item? This is how you need to pass the values. Score table, which is the table variable you created here, then you are going to use the function get underscore item, and the parameters for it is key. What is your key? It's the player name, which is the partition key, and the sort. You don't have to give the sort key, but if you give, it will get you the latest one or whichever timestamp value you passed. And then end time, duration, print data, you are going to print all that. Got it? Let's run it. Is this what they wanted to run, or is something else? So let me go here. Yeah, just the file and then run it. And it ran successfully. And you can see the record here where the partition key is James Smith and the timestamp is that one. Right? So these are the things that you need to remember if you have DynamoDB at your project. So you need to create a DynamoDB instance, whatever it is. Then it has this function or method table where you need to pass the table, then create it. Then it has get item to get a single record or item. And these are the parameters you need to pass. This is the takeaway from this particular one. Then let's go back. Okay, oh my god. Okay, let's go here. So we already got this, which is good. And then they want us to open the player score query. So we are going to query a particular player score, I am assuming. So let's see what it is. So here we are not going to, I think, scan the entire table here. Instead, we are going to use the query operation. So the query operation finds items based on primary key values. We already learned about it, but you have done it using the GUI. Here you are going to see how to do it using Python. You must provide the name of the partition key attribute and a single value for that attribute. Query returns all items with that partition key value. Optionally, you can provide a sort key attribute and use a comparison operator to refine the results. So let's go back and open score Python script. So this one, table name, they parameterize them. But if I go back to our actual code, which is this one, same thing, DynamoDB, score table. But here, instead of get item, they are using what? Query, which is similar to whatever we did on the GUI. So what did we pass there? We passed the partition key. Same thing, we passed player name as James Smith. Here also we are going to do the same thing. So we expect the same results, whatever we got there. So let's go here, let's run them. And as you can see, printed 5 of that many records. Don't think, oh, there are only 5. There are 3,508 records, but we only printed 5. How did we limit that? I think somewhere in this one of the has it maximum records to print. They are passing it somewhere in there. That is making us only print 5 of them, as you can see here, right? Anyways, the point is we can query using the query method similar to the GUI, and you have to pass definitely a partition key. Nice. This is the practice, right? They are going to hold our hands and show us each and every step. Then as a DUI, they will leave it to us. Okay, once that is done, they are asking us to click this one because we are going to change, I guess, because previously we queried everything for the player James Smith, but here we are going to filter. Remember, we added 2 filters previously, wherein the batch is equal to champs, etc. I think that's what they want us to do. So they want us to uncomment whatever they already placed. So they already placed it. Less job for us. So if you go here, they already commented this. So if you want to apply a filter, how do you have to do it? This is how you do it. What is it? Attribute, you mention it as attr, which is the column name. Then you are going to use which means equals to that. So here we are telling the filter expression where badge is equal to champs. And if you run this, it has to return less records. There are only looks like 3 records that for this particular name, the batch is champs. Okay. So this is the first query. Don't worry about it. After that, even they have to get only 3 records, or maybe they got more than it, or did they run it? I don't think they ran it yet. So what they are telling us is go to file, then save. Okay, then run it. Oh, they got the 3 records, which we got it, but we didn't save it. So let's go and save it. Oh, it's already saved. Maybe if we run it, it will automatically get saved, I guess. Oh, maybe not. Save it, which we did. All right, cool. We got 3 records. They got 3 records. Everything is going smooth. Well, this is practice lab. Obviously, it is going to go smooth. We will get blocked when we do DIY. A filter expression is applied after a query finishes, but before the results are returned. Therefore, a query operation consumes the same amount of read capacity regardless of whether a filter expression is present or not. Remember, consumed capacity is 29, just like the previous one, wherein I can go there and do that again. If you come here, how long did it take? 28.5. How long did it take? 28.5. So why same? Because the query will be executed first, then the filters will be applied. So for that reason, it will be the same. Then they are asking us to what? Uncomment limit equals to 5. Okay, which we can do, but it won't help much here because we only have 3 records. All right, once we do that, okay, limit parameter is the maximum number of items to evaluate. Oh, okay, I thought it will only going to return 5, but that is not the case here. To evaluate, not necessarily the number of matching items, which is what I thought. An empty result is returned when there are no matching items found after evaluating the number of items defined by limit. If there are any matched items found, the order of the records will be returned in the order of the sort key. The limit constraint impacts the consumed capacity and duration, obviously. So what they are trying to tell us is, if you uncomment this limit equals to 5, it is going to only check for this particular filter within first 5 records. If this doesn't apply in the first 5 records, it's not going to return anything. So let's run this. I think we should not get any records according to them, which is not, which means whatever 3 records we got are after 5 records. Okay, make that clear, because the normal SQL, it is different. When you put limit 5, it is going to give you, it is going to limit the results that it prints to 5, but here the filter expression makes sense because here the filter expression is evaluated after you got the record. Okay, makes sense. Anyways, so that's about the limit, which is good. I learned something new. And then they want us to do what? Pagination. Pagination, if you don't know, I think in APIs you will hear about pagination. I think even in SQL. So what they are telling us, open the file, the bottom file, then review this code that they wrote. With pagination, scan operation results are divided into pages of data that are 1 MB in size. Okay. Most of the time you will see this in APIs, wherein if you have data more than a certain limit, then it is going to give you as pages. It won't return you in a single page. Instead, it will tell there are this many pages, then you have to query each page to get that particular data for that one. If the total number of scanned item exceeds the maximum data set size limit of 1 MB, the scan stops and results are returned to the user as a last evaluated key value to continue the scan in a subsequent operation. The results also include the number of items exceeding the limit. A scan can result in no table data meeting the filter criteria, which we have seen earlier. So the thing you need to remember is last evaluated key. Using that, you can query the next page. So let's go and review that code, which is in this one. Where do they have it? I think maybe here. Which file is this? Player score scan. Never mind. Is that the one? Yeah. Oh, okay. Here we go. Okay, so they are going to check this one. If this is null, which means there are no more pages to loop. So that's how they are evaluating it. And then you can get the player data using the last evaluated key, and you can print it. Cool. Okay, they want us to run this. Look at the query. You need to learn the query. There is no other, how to write it, etc. Okay, so printed 10 out of 29 records. Okay, there are 29, but it only printed 10 because in other page you have other 10 and so on and so forth. Okay, and then you got the 10 records as you can see here. Oh, they want us to copy this. Why? Go to your dashboard, which I will do. Because the scan operation reads the entire table, it consumes more capacity units and takes a longer time to complete. Makes sense. So they are telling us to copy this for some reason. Let's do that. And they want us to go to your dashboard, then tables, player score. Indexes give you access to alternate query patterns and they can speed up queries. Click player score. Oh, they want us to, oh, okay, now it makes sense. So there are no indexes here, so that's why it took this time. So they are going to show us to create an index, and they are going to show, see, after creating index, the time reduced. A secondary index is a data structure that contains a subset of attributes from a table along with an alternate key to support query operations. DynamoDB supports two different kinds of indexes, which is global secondary index, which is an index with a partition key and a sort key that can be different from those on the base table. You can create one or more global secondary indexes at any time. Whereas a local secondary index is an index that has the same partition key as the base table, but a different sort key. Local secondary indexes can only be created when the table is first created. Okay, you cannot create local secondary indexes after the table is created. So let's go there, indexes. Let's create an index. And we are going to create a global secondary index as partition key as batch and sort key as game. When you create an index, you define an alternate partition key and sort key. You can also define the attributes that you want to be projected or copied from the base table into the index. This gives your applications more flexibility when querying your data. And we need to name it batch game index. So let's go ahead and do that. I think I will go here and pick DynamoDB again. Tables, click on this, indexes. Let's create index, and again you can only create global secondary index because the table is already created. Local secondary indexes can be created only while you initially create the table. Partition key is what? Player name, I think, or batch. And the sort key was core, if I'm not wrong, or game. Okay, it already created the index name, which is good. Okay, what else? Okay, that's it. We have to create, then we will go and explore the table. Each table in DynamoDB can have up to 20 global secondary indexes, which is default quota, and you can have 5 local secondary indexes. Remember that. Once we go there, we choose query again. Here, instead of table, you are going to query the index, and then the partition key batch, and we are going to type champs. I think that's it. Then they will run it. A GSI is considered global because queries on the index can span all the data in the base table across all partitions. GSI is stored in its own partition space away from the base table, just like the traditional databases. When you create an index, it will have its own separate table created and stored data there. Okay, you ran it, view table details, click it. It consumed 0.5, items return 29. And when you click there, go to CloudWatch metrics. You can monitor DynamoDB using Amazon CloudWatch, which collects and processes raw data from DynamoDB into readable near real-time metrics. By default, DynamoDB metric data is sent to CloudWatch automatically, which is good. And then what are they telling us? Go to review the latency, the time it took to run it, I guess. Obviously, which will be much faster. Now they want us to query index that got created. And basically what they are telling us, see the time. It only took 0.5 seconds after creating the index. I think that's about it. So let's go back and do that. So here, how long does it take to return 29 records? 220 capacity it took, not the time, 220. But after creating the index, they are telling us how long it will take. Let's see, go ahead. Let's create the index, which is created. You can go here, explore tables, query, and we are not going to query that. We are going to query the index, and the batch is, I think, champs. Is it capital or small? I don't remember. Let's try this one. Okay, let me run it. Seriously, I just created it. Is it not batch game index? It is. Oh, maybe it is talking about this one. Okay, is it not created yet? Is it still getting created or what? Creating, it's still creating, never mind. Even though this said it will only take 5 minutes, it took more than 5 minutes. I mean, this is not even a big table, and if it took 5 minutes to create an index on such a small table, I can only imagine. All right, let's go to tables now. Let's click here, not click here, select here, explore. Now let's do the same thing. I think this is capital C. Now that is created, this should run fine. And how long did it take? 0.5, and it returned 29 records. Remember, 29 records, but how many compute capacity it consumed? 220, and here you can see 0.5 because of the indexes. That's the powerful nature of indexes. So now let's go here, and I think this is our index. Now let's run it from here. Similar, whatever we have done here, this does the same thing. If I run, it should take only 0.5. It should only consume 0.5 capacity to give 29 records, and which indeed it did. So that's all about the practice session or practice labs. Now we have learned a lot of things. Now you even know how to use Python to get items query from a DynamoDB table, and you also know the pagination code. Let me scroll slowly so that if you want to see, you can see it. I think the pagination one is right here. Okay, if you want the complete code, let me scroll a little bit slower. Here you go. All right, and we already know how to create a global index now and how it works, etc. That being said, let's go to our exciting part, which is the DIY. And here is where most of the time we get stuck. And how do we make sure whether the DIY we did is right or wrong? This is how they do the validation. So what are they asking? Create an additional global, which is very easy. All they are asking is use game and score, which we can do. Our test servers will search for the top 5 scores from each game. That's why we are using these two, right? Top 5 scores. So that's why the sorting key is on score, and top 5 for each game. So that's why our partition key is game. It will use the global secondary index that you created to query the table using the game name as the partition key. The test servers will retrieve the top 5 player records with player name and game timestamp attributes. Hint, we don't need any hint. We already know this is a very easy one. But my only problem is I don't know how long this will take again. It took 10 minutes to create the first one. Let's hope it will be faster this time. And by the way, they told us to go monitor CloudWatch metrics and latency here, right? Which is super fast. If you want to, see the metrics for that. Okay, let's go ahead, create it, and the partition is game, sort is score. I think pretty much that's it. Let's go ahead, create it, and I will come back when this is created. It took almost 10 minutes, 5 to 10 minutes for that to be created. So let's see how long it will take this time for this to be created. Alright, it's finally done. I think this one didn't take as much time as the other one. Any case, which this is done, that's all I care. And what is this asking about? It is asking about the global secondary index name. Just copy paste that because that's what we create. Let's click valid. And by the way, this actually works. Sometimes I think in previous projects I did give something not correct and it did fail. So this is not like you put anything and it does validates or it gives your result correctly. No, you did it. You created an index for the player score. Now return to the city and give your customer the good news, which is what we do. And this is a very small DIY. Usually some DIYs are really involved, but luckily, yeah, I think it's about 1 hour we started. So this is amazing. Our code dashboard is super fast now. Yeah, I know. 220 versus 0.5. Choose the new look of the island entertainment area. Choose your reward. I don't like any of them. No, this has fruits. Let's select that one. All right. Okay. Oh, I don't know. Yeah, fireworks. Thank you. Okay, we leveled up to 70. Amazing. And congratulations, design a delivered and feedback time. So I like it. I like some new things. So 5-star, and it's time for you guys to go ahead and hit the subscribe button if you haven't already done. If you did, that's amazing. Enable the notifications, like, comment, share, which really helps this channel a lot, and I really appreciate you all doing that. That being said, we are not done yet. Okay, so stick around. Now it's time to zap these drones. So let me make this full screen. Actually, it's time to zap the drones. How do we do that? Click on the zap drones, and I think I need to use both my hands here. Route and go, which is here. Let's click on that green. Now they will ask us questions, as I mentioned. Let's hope we answer them correctly. An Amazon DynamoDB table uses song ID as the partition key and has no sort key. Other table attributes include singer ID, singer name, genre, launch year, album, long song duration, and officer. Which action is the best way to find the most viewed songs launched in 2010 by singer ID? So the by singer ID is giving away that we need that as the partition key. And since the partition key is different than our base table, because the base table has song ID as the partition key, we cannot create a local. It has to be a global secondary index, which is what I think all of these are pointing to. And this one is saying Singer ID partition, oh, all of them are Singer ID partition, never mind. Then they said find the most viewed songs launched in 2010. Okay, so we can use 2010 as a filter. Most viewed songs, maybe sort the number of songs or number of views, right? So let's see which one is talking about. And launch year as the sort key, no, that won't work. Number of plays as sort key, I don't think that will work as well. I think it is this one. Launch year and number of views as the concatenate sort key. I mean, even this I feel like, because when you do this, you might get that are in other years. There is no information about does it contain only 2010 or different years. If it have different years, they don't have any filter. That is weird, don't you guys think? But I think this one comes close because it has number of views. This has number of plays. Do we have a number of plays column? I don't see number of plays column at all. So this is gone. And using launch year as sort key won't work at all. I think it has to be this. But again, I would prefer having a filter on launch year to 2010 if you have multiple years. But this will give you based on the year. I think you can pick 2010 among it and then get it, I guess. And we are correct. So when you get your answer right, you will get a card, and the card we got is for a DynamoDB streams. Let's collect it. So it's that simple. It's just question and answers. Let's go and zap another one. But this one is an orange one, which we won't, because for that we need plenty of cards. Okay, how long am I going to zap them? Once I figure out they are repeating questions, I will stop them. Okay, so it is asking about Kinesis. I don't know why it is asking about Kinesis data Firehouse, because we didn't do project, but I'm assuming it's based on my previous projects. Which AWS service can streaming data be loaded into using Kinesis data Firehouse? Select 3. And I think you can pretty much do to this, this and this. I think it's not RDS. We can click a hint and see, but I'm pretty sure. I think it's RDS. It's not, but see, we'll see. Yes, we are right. And we got AWS Systems Manager. I will take that. Yeah, I think we are already out of questions for the DynamoDB. That is weird. Usually it will at least ask 2-3 questions. Why I am saying it is asking about Kinesis. Usually the questions are based on what we just did. The project we did is on DynamoDB. It only asked one DynamoDB questions and it is going to others. That tells me that it is out of the questions. So after this I will do one more question and I will see if it is going to ask DynamoDB. If not, we can end the question session. Which method is used to publish data to Amazon Kinesis video stream? Which method? It is not that. It has to be put media. Yeah, I think it is put media. Either it is this or I think it is this. Yeah, we are right. We got a RDS read replica one. Let's do one more question and test if it is going to. This is an orange one. Do you guys want to try that? Let's try. Most likely we won't have the cards, enough cards, but let's try it. So it would need ELB, EC2 and that cards. Let's see. It will show us if we have the cards or not. But I just wanted to show you how this would look like. So this is how it looks like, and looks like we have all the 3 cards, which is good. So what is it asking? To help streamline content management for your web application, you want to add shared highly available storage to the web application servers. Add the missing ones. What are the cards we are needed? It is already shown here. We need EFS, ELB and EC2 instance. And we already know and elastic load balancing will be immediately after that. So where do we have that card? By the way, I end all these cards by zapping the blue ones. Okay, once we have that, what do we need? We are going to, ELB is going to talk to EC2 instances, so which will be the next ones. So place 2, but they have to be sharing same file system, and the only one that they can use is EFS. They can use EBS as well, but it has to be a specific type of what is it called? A specific type of EC2 instance, the Nitro instances. Okay, you can use EBS multi-attach as well, but I think this should be correct. Yes, it is indeed success. All right, I think I will end this session here, and thank you very much for all of your your time, and do continue. I think we have about 14 projects in this. I hope you like this project. If so, just subscribe and then click on the like, share, etc. See you in the next one. Peace out. Have a great day.